Okay, got the recording going. I haven't heard today how Valor's doing, whether he's going to be here or not. So definitely want to make sure that I record from the beginning, unlike what I did on Tuesday. Get my volume back up and go ahead and share the screen. Okay, so I was trying to write down anything definite I could think of because there's some questions that we'll have to answer in terms of the test, but those mostly will be answered next week. I am going to write a little bit. Nothing's really changed in terms of the format of the test. There's so many sections. I feel like I've checked this a million times. I will check it one more time. Oops. Okay, I think I've got it up there. I wanted to make sure I got those sections right. So today we are finishing chapter 6. Hypothetically, we'll see. There's not a lot of different concepts to learn in 6.8. Really, there's just one big concept, but there's quite a number of problems because that one concept can appear a ton of different ways. So I want to make sure that we look at it thoroughly. So we'll be talking about 6.8 and then Thursday. I am just like not with it. Thanksgiving break did a number on me. Today is Thursday. Let's try this again. So next week, next Tuesday, we will just go ahead and dive into a review of chapter 6. And hopefully that will involve you guys working some problems, me working some problems, trying to basically review as much of chapter 6 as we can. So pros and cons about that, I want to be able to cover exponent rules. I want to be able to cover factoring. So we may not be able to go as in-depth. So if it looks like everybody is just up a creek and we need another review day, we can always do that. But I definitely want to put Tuesday as a review day of chapter 6, where you guys can get all of your questions answered, get some practice. Prior to us thinking about the test, so the test will be 2 parts, an open book part and a closed book part, and I want to send those out to you guys at the same time. Two separate documents, basically, I'll attach to an email, and so when you're ready to handle 6.1 and 6.2, you can print that section. Just because it's open book, I wouldn't go into it blind. I would make sure that you have some exponent rule problems practiced pretty well. And the worksheet will help with that. So the worksheet, as always, will really mirror the test. It'll be 2 parts. I'll send it out over the weekend. And just like you do with the normal worksheets, pretend that it's your test. So on the open book part of the worksheet, go ahead and open your book. On the closed book part of the worksheet, close your book, just so that I can accurately see if you're getting a handle on the problems that we've got to test on. So in terms of due date, so basically the worksheet, I'll send that over the weekend, definitely, just so that you can have it in your hand early. My normal expectation is that people don't probably want to tackle the worksheet until after we've had a review day. But
wait, so are you going to,
yeah,
did you already send out?
No.
Sorry, did you already send out
No, I will send it out over the weekend. Yeah, I'm sorry, that says sent out over the weekend. Like, let me revise that. Will be sent out over the weekend. I was trying to be short in my writing. So is this the 3rd? So tomorrow is the 4th. So 12/5, 12/6, something like that. So the upcoming weekend. Yeah, thank you for clarifying. So that will be in your hand. Basically what I'm saying, that'll be in your hand before we do our review. But I have no expectation that you'll actually do it before the review. We haven't talked any due dates, and I'm not talking any due dates yet. Mostly because I want to make sure that Valor's back on his feet. But I want, if you guys want to dive into it, particularly because it's 2 parts. If you, one thing about it being a 2-part test and a 2-part worksheet, it gives you the opportunity to kind of really focus like on 6.1, 6.2 separately from the factoring. So if you feel like you want to kind of get that out of your life and go ahead and take that part of the worksheet, you could do that, and then with the expectation of taking that part of the test. So I will send the test out. So early next week. So the worksheet will go out first. The test will go out a little bit later. I usually write them about the same time. So just my preference is that everybody's got everything they need in their hands as early as possible, even though I have absolutely no expectation, again, that that means that you're going to start taking things the minute that they show up in your inbox. It's mostly so that I don't forget to do it. So 6.8, solving equations by factoring. And keyword there, factoring. Basically, we're going to be using what we have learned in 6.5, 6.6, 6.7, 6.8, all of those sections. We're going to be using those to actually solve some problems and to make maybe a couple of practical applications. I'm not sure, see how far we are able to get. But before we talk about that, we have to back up a little bit and think about a property of numbers, just plain old numbers to start out with. I had the page and then I lost the page. Okay, so let me be clear here. This is where 6.8 starts. Okay, so let's suppose we are multiplying just 2 numbers. The book would say these are 2 real numbers. I'm just going to say they're 2 numbers, 2 ordinary numbers, just like we normally would. And we're going to call those numbers A and B, just to match what the book does. You could call them X and Y. So we're multiplying them, so we have A times B. Let's also suppose that we kind of know the ending of this multiplication. So the answer of a multiplication problem is called a product. So let's say we're multiplying the 2 numbers and we just happen to know that the answer is going to come out as 0. Let me think of a good way to ask this question. Unlike any other multiplication in the world, there's not a really great way to say this without being confusing. So if you don't get what I'm driving at, that's fine. If we have A times B equals 0, what do we know about at least one of the numbers? We could know this particular piece of information about A, about B. It could be true of A, it could be true of B, or it could be true of both of them. Any ideas something that has to be true about one or both of these numbers in order to get 0 as the answer.
That one of them's negative?
Not negative, because remember, we are multiplying. If we were like adding or subtracting, I guess we should say, yeah, absolutely. But when you're multiplying, how can you force the answer to a multiplication problem to come out to be 0, basically? Zero is a really, really unique number.
I don't know. I'm sorry.
Okay, let me give a couple of hints. What if we know that A times B equals 6, for example? Do we necessarily know anything about A and B? Well, not really, because you could have 1 times 6 or 6 times 1. You could have 2 times 3, 3 times 2, and these are just positive whole numbers. I haven't even gotten into the fact that you could have, 12/13 times 13 over 2, for example. I haven't even gotten into the fractions, and I also haven't gotten into the fact that you could have negatives. So all of that to say, wow, that came out sloppy. I'm not sure why a miniature 6 showed up there. All of that to say, if I have just a regular number, I know that A times B equals 6. I have absolutely no clue how that 6 would have appeared. And that's true for any number in the world. I know all the possibilities, or some of the possibilities, but I don't know for sure which one of those pairs of numbers was 6. Same thing if you have even a smaller number like 1. 1 seems easier on the surface because, you have 1 times 1. But what about -1 times -1? And then similarly, what about all of those fractions? So 16 29ths times 29/16. Any two fractions that are reciprocals of each other, those will all come out to be 1. So even though 1 seems like a really simple number, there's really an infinite list that we could come up with of numbers that could multiply to be 1. So ordinary multiplication, all of that to say, ordinary multiplication doesn't give us any clues about what's A and what's B. Okay, but think about trying to get 0. If I have A and B as regular non-zero numbers, 2 and 4, -14 times 3/7, things like that, those pairs of numbers, negatives, positives, fractions, whole numbers, they will never ever come out to be 0. There's really only, you could say, one way that we can ever get a 0, and that's if A or B or both of them, you got to have a 0 in there somewhere. That's the only way to create a 0 by multiplication, is if one of those numbers is 0. Both of them could be 0, and that's great, but really we just need one of them to be 0. And this is called, this property right here, that is what the book is calling the 0 factor property. So only number in the world where this is true. Because if I am multiplying to be 20, for example, neither one of my numbers have to be 20. If I'm multiplying to be -75, neither one of my numbers have to be -75, kind of like we were seeing in those lists I was writing out. There's all kinds of ways you can get 20 or -75, but 0 is really restrictive. If you want to get a 0, then you have to multiply 0 in there somewhere. So that's what we're working with today, the 0 factor property. We're just going to take it to kind of a higher level, because what we're talking about now is cases like, oh, I don't know, 0 times 9 or -18 times 0 or 0 times 0. Cases like that, where it's all numbers that we're used to dealing with. Of course, we have to now start incorporating that with x's because this is algebra. So what that is going to bring us to is we're still going to be saying a times b equals 0, but a and b are going to look a little bit more complicated. So for example, I think we can dive into the first practice problem because it's pretty simple. A is going to be, still will be a number, but it'll be a number that's disguised as an expression with x in it. So x plus 8, it's grouped together in parentheses, it's one thing, one number, and then times b, which is x minus 5 equals 0. So there's our a, there's our b. And the rule we just learned says that either a has to be 0 or b has to be 0, or it's possible that they could both be 0. And the directions on a problem like this will be solve. Okay, we haven't seen that type of directions in a while. Our directions have all been factor, and it's been a few sections. In fact, I think it was probably, yeah, it was back in a previous chapter, like chapter 4, where we had to solve something. Solve in algebra means you work the problem down to where you have x equals something. So we were doing that earlier in the class, but when we hit chapter 6, we weren't technically solving anything. We were taking like an expression and we were rearranging it using exponent rules, or we were rearranging it using factoring, but we never got like x equals 2. We kind of took a break from that. Well, we're back to hopefully getting x equals some kind of a number here. So the way that we can say this, we can say, okay, our factor here that's called a, that could be 0. So let me just write this whole thing out here. So this could be true. A, which is x plus 8, could be 0. Or this other factor, which we were calling b, that could end up as 0 as well. So b is the quantity x minus 5. And what that gives you are two very simple equations in terms of x, where all you have to do is isolate x. You have to get it alone. So I haven't done this in a while, so we'll go ahead and put in the extra step. If I subtract 8 from both sides, I'm left with x equals -8. And then similarly, I'm going to add 5 and I'll get x equals 5. So in order for this equation to equal 0, either x has to be -8 or x has to be 5. So there's a couple of ways you can write your answers. It's been an age and a half since we've done this. So you could write, kind of box in what you have, or if maybe you want to be more condensed, you could say x equals -8, 5. Or another way to write that solution set notation with the curly brackets, you could do that as well. So I think a lot of people, once they get down to x equals a number, they like to just box that in and be done with it and not have to like rewrite it with the brackets. But just so you know, you'll see that in the book. They really, really like the solution set curly brackets. Okay, let me stop there. Any questions about what I just did? Okay, it's it's a simple concept. The problem is they are not always going to hand you a nicely factored polynomial like they did here. And they're also not always going to hand you a 0 like they did here. It's really important I'm going to write that before even really explaining what I mean. Okay, so if we want to apply this zero factor property, there are two things that we need, and sometimes we're given both of those, sometimes we're given neither of those, and sometimes we're given like one but not the other. So we need a completely factored polynomial. And that completely factored polynomial is going to have to be always set equal to the number 0, no other number in the world. So what we were talking about earlier, how 0 is so unique. If we see a 6 or a 1 or a 4/7 on one side of our equation, we can't yet apply the zero factor property. Now, it doesn't mean we get to throw the problem out. It just means we have a lot of prep work to do before we get to actually solve. So the 6.8 requires, I guess we could call it a lot of housekeeping on our part before we actually get to the method itself that we're trying to learn. So that's a little bit unfortunate because we want to just dive right in. We're learning a new method. We want to dive right in and apply it. Sometimes we can't do that. So for example, practice problem 2 starts moving in that direction slowly. Okay, so the instructions, once again, will no longer be to factor. The first thing I write down is going to look very much like what we were doing prior to today. You have a polynomial. So ordinarily, the directions would say factor, and that would be all I would see. But now it says solve, which means there has to be an equal sign. And I've got the 0, so that's good news. I have the second part of what I need to have. I have something equal to 0. The problem is I do not have a factored polynomial. So what I need is something that looks like that. I need it nicely grouped to where it's, remember how it's called the zero factor property? Factor meaning you've got a couple of things that are multiplied to one another. So I need to factor this polynomial before I can solve the problem. So if I have to factor a polynomial, that means back to what we talked about on Tuesday when we were reviewing factoring. That means I have to remember like a completely other set of rules right now. I have to remember, how do I factor? So to factor, there were two things that we talked about on Tuesday. Can anybody remember what is the first thing I should always do when I'm factoring? I could say, what's the first thing I should look for?
You have to find the GFC.
Right, yeah, is there that overall greatest common factor? And in our case, between 3 and 10 and -8, there is not one, there's not a greatest common factor except for the number 1 itself. So that means we can move on to the second step, which is counting those terms. Okay, so we are counting the terms and we come out with 3 terms. So 3 terms, that means what we want to try is that AC method. We want to take our 3 terms and expand them out into 4 terms and then apply factor by grouping. So I'll add that to today's notes as well. Factor by grouping. Okay, let me rewrite. We've got 3x squared plus 10x minus 8. Okay, and just to get in a little bit of a review on this, I am just going to kind of throw you to the wolves for a minute. See how far you can get with that. If you can get all the way to the end, that's great. If you can just get 1 or 2 steps down and then you want to check it with me, that's great too. Just whatever steps you can take just to kind of get us back in the mode of factoring.
Okay, I think we got it.
Okay.
Okay, so we got in parentheses x plus 4 end parentheses and then in another parentheses 3x minus 2.
X minus 2. And I think that's what I got as well. I just happened to flip off of that page. So let me go back to that page. Where is it? X plus 4, 3x minus 2. Yes. Okay. So, and this was now set equal to 0, set equal to 0. Great. Okay, so that's the factored form. So what we do at this point is we just pull this thing apart. We set x plus 4 equal to 0. We set 3x minus 2 equal to 0. And you don't even have to use the word or. That's what I was writing initially because it ties back into the way they write out the zero product or the zero factor property. You can just write the two things set equal to 0, move everything around. That's super easy in the case of the x plus 4 equal to 0. A little bit harder with 3x minus 2. So unfortunately with that, we would end up with a fraction. I guess it's not too unfortunate because we don't really have to do anything with that fraction. We just have to divide away our 3 so that the x is completely isolated. And that means our final answer, if I kind of bring it all down here together, is that. So included in most of these problems is going to be a complete problem from like chapter 6.7, 6.6. So you have to be able to apply any and all factoring rule that we learned. But then you have to be able to take it one step farther and actually solve for x. And the book points out you can always, to check your work, just continuing what we found out all the way through most of chapter 6, you can always check your work here. Take these numbers, take these x's all the way back to the beginning before you factored, plug them in, I would say with the help of a calculator so that you're not there all day. But if you really, really want to check, you can go back, plug those in, and make sure that they create a 0 at the other end. The harder the problems get, I'm not a huge fan of doing that, but it's always good to know that there's something you can do besides reworking the problem. Because sometimes, I always encourage reworking the problem on the test, but if you don't have time, it's nice to have something else in your back pocket just so you can walk away from the problem in the end and feel like you've got a good handle on it. Okay, so in a nutshell, that's all we're doing. We're going to be factoring things and then setting their pieces equal to 0, getting a couple of x values, boxing them in, and we'll be done. The problem is things start looking even trickier from here. So the next practice problem, let's see, still page 348. They start messing with our minds because not only do they, well, let me not even say anything. They start messing with our minds. Here's what they give us. At first glance, that looks great because that is a factored polynomial. But notice that they set it equal to a number that is not 0. So I'm going to put that in the notes. That is a big deal, not 0. So back to those 2 rules for applying the 0 factor property. Rule number 1 is you have to have a factored polynomial, and we have that. But rule number 2 says that factored polynomial has to be set equal to 0 only. So we have a problem. We cannot, and this is where understanding the 0 product thing is important. This would be bad. Let's say we just dove into this and said, well, if x times 3x plus 14 equals -8, then surely either x equals -8 or 3x plus 14 equals -8. This is really tempting to do when we're starting out with this method. But remember that -8 or +1 or +15, any number in the world doesn't have that property where it requires one of its factors to actually equal itself. Only 0 has that. So doing what I've done here is just not good. What we need to do, unfortunately, it's going to feel temporarily like we undo what they gave us, because they gave us something that was nicely factored, and we're going to mess that all up. We are going to multiply out the x times the 3x plus 14 and then add 8 to both sides. And it feels really awful to do that because we hate seeing something factored and, again, like I said, messing it up. But that's the only way to get past what they gave us because they're being really tricky. So here's what they gave us once again. Equals that -8. So against my wishes, I'm going to multiply out that x. So I will get 3x to the second power now plus 14x equals -8. And then because I need to add 8 to both sides, I will say +8 real quick. The reason for doing the +8 is that it creates the 0. I can always go back and refactor, as messy and unfortunate as that is. I can always go back and refactor, but I absolutely need to see that 0 sitting there. So a good rule of thumb we need to see that 0 on one side of the equation before any factoring happens. Okay, so they tried to trick us by giving us something that looked factored, but because it was not set equal to a 0, their factoring doesn't count. So we have to get back out of their factoring, move the 8 over. Now we've got a polynomial that we can work with on our own. Okay, so this is probably, I would say, the worst case scenario for these problems, where you have so much algebra to do before you can even get to the real algebra. You have to clean the problem up, move everything around, and only at that point can you factor. So here, to factor this, we revert back, as always, is there an overall GCF? And nope, just the number 1. So we count the terms, and there are 3. So this is going to use the same method that we used a minute ago, the AC method. So extra practice once again. You guys did great with the last one. Dive into this one and see how far you can get with that. This is a little bit nicer in one sense. There are no negatives, so that should make it maybe slightly easier than the last one. I don't know.
Okay, so I got it. It's 1 parentheses x plus 4, next parentheses 3x minus 2.
And I think it should be 3x plus 2. Let's see. Because there is no negative in this.
Oh, I'm sorry. I forgot that I moved the x over and it changed the sign.
And that's weird. Now that I'm looking at this problem factors out almost identically to the one you guys did last time, because what you just said with the -2 in there, that's actually the answer to the practice problem previously. It's weird. They give you 2 in a row, but they factor like almost down to the very end. They're like identical. Okay, so we get that, and then so x plus 4 will equal 0, and 3x plus 2 will equal 0. So very similar to what we did a minute ago, apparently. We get x equals -4, and we get x equals, if we move by subtraction, we move that 2 over, we get a -2. Divide away the 3, eventually we get a fraction once again. And as an illustration of what I was saying a minute ago, if you want, you can just box those two things in right there. You don't have to worry about bringing them together into a single list or into a pair of brackets. Okay, so the remaining few problems here, it's really just more of the same. They just start giving you messier and messier things in terms of what they ask you to solve. They all usually end in pretty basic factoring, but they start out just looking all kinds of weird. So for example, there's this one, 4. Okay, so there is not a 0 in sight, and it looks like they tried to give us a little bit of factoring, but without that 0, again, we don't care. So what we're going to do is rewind everything that they have factored and just start moving everything around. We're going to work this down to where we have a polynomial equal to 0. That'll be the first thing that we do. And then the second thing that we do is to make it a factored polynomial equal to 0. So it'll take us a while to get to where we have what we need. And notice that all of my zeros are landing on the right. All of the book's zeros are landing on the right. That's not necessary. You could put a 0 on the left if you want. It's just one of those, we do it this way because we always do it this way. So it's not a, you could factor with 0 equal to your polynomial, and that would be fine. Okay, so if I'm distributing everything out, I'm going to have 8x squared plus 24 is the result of my first distribution. I have that plus 4, and it didn't need the 8 distributed to it because it was not in the parentheses, so I just carry it down. Then I get -8x squared minus 24x. And then similarly, that plus 19 is just hanging out there on the right, so I'm just going to bring it down. And as we did, gosh, way earlier, I don't even remember what chapter this was in, if you can find any like terms that are on the same side of your equation, now is a great time to go ahead and add or subtract them together. So I think that's only happening to me once. So now I've got 8x squared plus 28 on the left. But anything I can do to making the cleanup here simpler is helpful. So I went ahead and did that. Because I like my 0 to end up on the right, I'm going to very carefully start forcing everything over to the left. So for example, you could say, and I'm doing this in way more steps than you need to, just for clarity's sake, since we haven't yet done a problem quite this messy. So I am basically moving one thing at a time. that 24x or negative 24x, it's up to you when you move that. It doesn't have a buddy over on the left-hand side. So I might actually kind of, based on how painstaking I'm being about this, I might save it for the end and focus on my like terms first. Okay, so what is that? 9. And then last thing, if you want to add the 24x over, it will not have anything to go together with. I'm going to tuck it here in the middle. Like that. So at long last, a lot of things needed to be added or subtracted over, but I finally have a polynomial equal to a 0. And of course, having that polynomial, I have to ask myself, as always, is there an overall GCF? So you pause for a second after all of that algebra, and then you're on to more algebra, but of a different kind. So it looks like, once again, I guess we can be, whoops, I'm writing that. I should be writing except 1. We can be thankful that they're not really giving us a ton of GCFs right now. So overall GCF, don't have one. So that means we go straight to counting the terms. And there's 3. So that means do that AC method. And this one, I'll go ahead and show you guys. I worked it out earlier because I was trying to stay ahead of what they were doing. And this one looked a little bit messier than what we have had to deal with. And it is. So we've got 16 times 9 comes out to a relatively big number, 144. Now, thankfully, because there are no negatives in the whole problem, I don't have to think about the fact that like -1 times -144 would give me what I need here. I can just stick to positive. So 1 times 144, 2 times, what's that, 72, 3 times 12, 13, 14. Do you guys know the trick with 3s, how to tell if 3 multiplies into a number? You just add the digits of the number. So 3 is always a weird one. I know that 2 goes into a number if the last digit of that number is divisible by 2. So the last digit is 4. 2 goes into 4, so I know 2 has to go into the whole thing. That's the rule for 2s. The rule for 3s is I add my digits. I get 9. If that number is divisible by 3, then 144 will be divisible by 3 as well. So that's how I knew that 3 went in there. And there's some similar rules like that, I think, for 6s and 9s. Unfortunately, the only one that ever sticks in my mind really well is the 3 rule, because it's so simple. 4, I just tested 4 out earlier. Right, 12, so that's 36. 5 does not. 6, 12. And as I am writing these pairs, kind of can see that none of them are adding to be 24 quite yet. And they won't for a little while longer. 7 doesn't work. 8 should work. Oh, yeah. 9 doesn't work. No 9, no 10, no 11, but 12. Finally, there at the end, 12 plus 12 will give us the 24 that we need. So that's what I meant about this problem taking a little more work than the last 2 that you did. We had one like this in the notes on Tuesday's class where I think it was 100 that we were factoring and 10 times 10 were the magic pair of factors. Okay, so there we've expanded And if all goes well, we should be able to pull out a GCF and a GCF and then get matching things there in the parentheses. So carefully, and I'm going to kind of redistribute in my head, make sure that I did that factoring correctly. Yeah, this is very much like the problem we had on Tuesday. We get the same thing twice, which that's a clue that the book would have preferred us to use one of those optional memorized formulas. But again, is there a need for that? Only if you want to add some extra memorization to what you've already got going on. So if you get duplicated factors like this, you don't have to write that out twice. You're going to get both times x equal to -3/4. That means you only have one answer. It doesn't matter that it's repeated. For you, there's only one answer. There is an algebraic meaning behind repeated answers, but it has to do with when we're drawing graphs. And in this problem, we are not drawing any kind of a graph. So after all of that extra work that we did to factor this, at least we get a little bit of a break at the end. We don't have to solve for 2 x values. We only have to solve for 1 x value. So I'm going to write no need to solve both factors since they are the same. Okay. So when these problems happen, you won't always get 2 answers. We get in the mode of getting 2 answers. We've gotten 2 answers several times in a row, but sometimes you're going to get 1. And just, you know, as a spoiler alert in future classes, you could get 0, 1, 2, 3, 4, depending on how complicated the problem is. Now, the problems they're giving us in this section, you can never get more than 3. Okay, so this next one, it's been a while since we have had to clear fractions out of anything. So of course, they can't let us get through a chapter without having us clear fractions. Now, this is one of those times when really it's optional. It's sort of a matter of personal preference. So I'm just going to try and phrase it in a way that demonstrates that it's generally easier if we clear the fractions before we do anything else. Because what we're going to have to do with this problem is move everything over so that we have a 0 sitting probably on the right side where we tend to like it. And then we're going to have to factor, and then we're going to have to solve. All of that gets weirder if you have a fraction. So just in general, it would be nicer if we could just get rid of that 2 that we have sitting down there in the denominator. So on the right side, you can multiply by a 2. And on the left side, multiply by a 2. That way your equation is kept balanced. Nice and easy on the left because 2 times 4x squared just bumps you up to an 8x squared. Over here, the right side, really the part of the equation that we're most interested in because it had that 2 to begin with. It's going to require distribution. So I have the 2 sitting out here to the right. You might be more comfortable sticking the 2 right here. I just didn't have a lot of room. Okay, so when we multiply the 2 to the 15 halves, it'll cancel the half part, but leave the 15 part and the x part. When we multiply the 2 by distribution over to that 1, it will stay a 2. So at this stage, we're no closer really to having a factored polynomial, but at least we don't have any more fractions. So this is kind of where the starting point of a lot of our problems would have been previously. So what I can do now is I can subtract that 15x over, I can subtract that 2 over, which I'll do a little bit quicker than I did in the last problem. Okay, and yeah, this is a good one. The problem I had done a minute ago was kind of wild and crazy, but this problem is back to a bit more normal. So I'll just put it in here for the notes. Still no overall GCF. We haven't had anything that was not 3 terms. But these were the rules that we had written down for factoring, so we are going to abide by them. Okay, so this is an AC method. So once again, I think this is the last one today where, yeah, this is the last one where it's just a good solid problem for you guys to practice. So see where you get with that. See if you can get to the end with that. And if not, of course, I can bail you out in the middle if you need.
So the only thing is 8 times 2 would be negative 16. The only set of factors that would work for that to add up to be 15 would be negative 1 plus 15. But then it would turn the problem into 8x squared minus 1x times 15x minus 2. But then on the right side,
So if you switched the signs, instead of negative 1 times 16, what if you made it negative 16 times 1?
oh, okay, I thank you. I got it.
Yeah, rewrite that down there.
Didn't think.
Okay, so then I got 8x plus 1 and then x minus 2.
Yes. Okay, so 8x plus 1 and x minus 2. And I'm trying to read my tiny little baby handwriting here in the book just to make sure. Yeah, that's where I had the negatives as well. Yeah, so when you get that situation where it looks like you're getting the right number when you're adding, but it's the wrong sign, then just try flipping your positives and negatives. So, okay, so what I need to do here, equals 0, x minus 2 equals 0. And by fiddling, moving things around, subtracting, dividing, I get a negative 1 over 8. And I get a positive 2. Okay. Now, just briefly, I don't think I'm going to go as far into this as the book does because it really takes us into the realm of problems that are more complicated than just your mainstream Algebra 2 problem that we're going to be seeing like on the test. But let's do the most basic one of these final couple of practice problems in the, not the final 2 in the section, but the final 2 in the teaching part of the chapter, or the teaching part of the section, not the application part. Let's say we've got this. Okay, so similar to what we've been doing, if I want to create that 0, I'm going to have to subtract 2x squared and 3x. Like that. Okay, so finally, they're going to give us something where when I ask, is there an overall GCF, it's no longer just checking a box. There actually is an overall GCF, and it's really just X. So I am going to factor out that X. And this gives me now, as we've learned, you still have to count the terms on what's left. So you have that X sitting out front. You're going to count the terms on the polynomial that remains behind. And there's 3 terms. This is one of those cases where you have kind of a nice, shorter process ahead of you. The fact that there's a 1 in front of your X squared means that you don't have to, if you don't want to, you don't have to go the full distance of multiplying 1 times -3. You can just factor your -3 in such a way that the factors add to be -2. And you can dive right into the part where you stick it in parentheses. You don't need to expand to 4 terms, do your factor by grouping, unless you just want to. It's the shortcut where you have a coefficient of 1 in front of your X squared. Okay, but of course, we had X itself sitting out front. So this is the first time where we have factored something and been left with 3 pieces. And what you'll have to do is set all 3 of them equal to 0. And that feels a little weird because the first one is literally just the letter X. It's literally just our GCF. And when you get to that point, you're done with that stage. You don't need to move anything over because you have X equals a number. It's the other 2 that require just the typical amount of work here. So,
Miss Savannah? I'm so confused at how you somehow, we were talking about doing something to the 3 and the X and all that. I'm lost from that.
If you factor -3, -3 can be 1 times -3 or -1 times 3. And it looks like it's the 1 times -3 that would add back to get you -2. I'm only factoring -3 here because if I did the AC thing, if I did 1 times -3, it would still just be -3. It's just a shortcut we can use because there's a 1 there. So these are the two factors, and if you want to, you can expand. You can say what used to be x squared minus 2x minus 3 can be x squared plus 1x minus 3x minus 3. So you can take what you had and kind of pull it apart and do the standard factor by grouping. That's always a safe thing to do. And you'll get those matching factors, matching GCFs. Okay. What's going to happen in the shortcut when we have, once again, it's only because we have a 1 sitting here, that's where the magic happens. When you go through that method where you expand and do your 4-term stuff, you are always going to end up with the 2 numbers here that you got way back at the beginning. So if you want to, when there is a 1 sitting out front, you're allowed to just factor your -3 in such a way that the numbers would add to be -2, and then throw those factors into your parentheses. Now, if the shortcut itself, because shortcuts are only good when we find them helpful. So if you think that's more confusing than helpful, because most of the time we haven't been given something with a nice 1, you can go ahead and do this out the standard way, and you will get the answer the way that we're used to getting the answer. So it's really up to you. Does that make sense, though, where those numbers are coming from? Move back over here. My finger went too far. Okay, so we got, those are our 2 numbers. We had it factored, and then in this case, we got 3 answers. So this is what I meant earlier when I said in this section, it is possible to get up to 3 answers. Not gonna happen very often. I'm torn. I haven't written the test, and I just kind of feel like I'm not going to get this far on the test, but I want to put it in the notes just in case. And if I do decide to put it on the test, that will be reflected in like what your worksheet looks like. Let me see if there's a good one that I can put on the homework that looks like that. You know what? No, let's just say this type of thing will be practice 6, not on test. I'm not immediately seeing a homework problem that I can guarantee is close enough to this. So yeah, it's not close enough to this. I don't want to do it. Okay, the only thing we have left to do is really see a couple of quick ways that this idea can be applied. And usually that means word problems. Sometimes, not always. The first thing I wanted to show you, and this is jumping all the way to the end of the section. So applications, there's several of them in the book, but I'm only picking a couple because one of them at least was way more work than it was helpful. So back at the end, we haven't talked about graphing in a while, but let's say that we've got some pictures, some graphs here. And it's really important that I get all of these horizontally in rows so that you guys can see what I'm doing. Here, remember, this is the x-axis. So we have like x equals 1, x equals 2, and off to the left we would have x equals -1, x equals -2. And my graph in this case, of course, these things are it cuts here through x equals 0. And once again, as I said, I am the worst at drawing with this thing. Oh my goodness. Wonder if I made a thicker line. That can make it easier or harder. Goes there. There. There you go. And yeah. Okay, so there's my first picture. Here I've got -1, +1, +2. If I expand, that probably would help if I expanded my so we're going to go through 1. Okay, something like that. And then finally, here, if I can leave myself room, I've got 1, 2, 1, 2. And this one, it looks like they're not forcing me to be quite as precise, so that's good. Okay, so I've got a U-shaped graph, and then I've got a couple of these. We talked a long time ago about how the lead term of one of these graphs that squiggles up and down would be like an x cubed. The lead term of a graph that makes a U shape would be x squared. That doesn't really come into play here. It's still there in the background. What does come into play is I want to notice where these things cross the x-axis. So notice that this crosses at x equals 0, at x equals 1, and right here, I am guessing that's like -1.5, maybe. I'm just eyeballing. This graph, it looks like it crosses at x equals -1, x equals +1, and not quite to 2, so maybe 1 3/4. I'm just getting a general idea of where these graphs cut through the x-axis. Same thing here at the end. This could be -1.5, but I'm not sure. This could be +1.5. Okay. So if you have graphs like this and you know a little bit about them, but you don't know everything about them, let's say that we are given match with these functions. So we're going to be given 3 functions, and I'm going to go ahead and call my graphs A, B, and C so that I don't have to recopy them again. So I've got this f of x. It's a factored polynomial. They've just gone a step farther and told me that it's a function. I've got g of x, and I've got h of x. Now, as weird as this problem is, and as long as the setup took, I wanted to include it because it's one of the few times we don't have to factor anything. They've done the factoring for us. Okay, so we've got f, g, and h, and these are the pictures of f, g, and h. We just don't know which one is which. So without dragging out a calculator or some kind of software, there's a quick and easy way that we can actually figure out who's who. And the way that we're going to do that, we talked ages ago about x-intercepts. And x-intercepts are really what I've circled for you up here. they're the places where your graph crosses the x-axis. So I've circled them and I've labeled them to the best of my ability. Some of them were guesswork on my part because they didn't cut through at a whole number. So finding the x-intercepts for us meant way back when letting y equal 0. Well, now what that means, because we know what function notation does, that means letting f of x equal 0. So f of x or g of x or h of x, all I have to do to figure out where my x-intercepts are is just tack an equal 0 to the right-hand side. And when you do that, what you end up with is really a problem just like what we've been solving today. So f of x equals to 0 means if I set those two terms equal to 0, I'm going to get either x equal to 1 or x equal to -3. It's pretty easy when you don't have to divide anything. You just move the 1 or the 3 over. The g of x, that would give me 0, -3, or +2. If I set each of these terms equal to 0, and then here, it would give me +3, -2, +2. So off of this, if f of x has two x-intercepts and they are 1 and -3, oh, you know what? That is so sneaky. Now that I'm squinting down at my book, I notice they have pulled a fast one. You know, I kind of want to just ditch this problem because of what they've done. They've changed the scale. Yeah, that is ridiculous. Sorry. I am going to remove this whole problem as if it never happened. We will talk about that because I'm going to have to restructure. So sorry about that. That's what I get for not looking at that. Yeah, that's going to take me too long to erase that. Let me just cross through this. That had the potential to be a really good problem and it went south quickly. You know how I told you these were crossing at like 1.5? It turns out that they wanted this mark to be like 2, this mark to be 4, but they didn't notate it very well. So me looking at their tiny little graph, we will table that discussion until probably next week. Okay, yeah, sorry about that. That needs work. Let me look at their example problem. Their example problem is great. That might have been what led me astray. I might have thought the practice problem went like the example. Oh well. Okay. The last thing that we really need, do you guys remember, I think it was chapter, wow, I'm not even comfortable saying what chapter it was. Do you remember problems that look like something like this? And they would say that h, I think it was back when we were learning about functions, h represents the height of some object that is maybe launched into the air or dropped from the top of a high building. In this case, it's a model rocket. It could be a stone, a ball. They're called projectiles a lot of times. A bullet, a cannonball. So h is going to represent the height of a model rocket that is launched from the ground. Previously, in a previous chapter, the types of questions that they would ask us would be something like this. Something like, how high is that rocket after, say, 1 second? And what that would require you to do, your 1 second is your time. So here we have h represents height.
Is this dirt? D equals RT.
No, it is not dirt. This is not a formula that you would ever have memorized. This is just something that they'll give you in the problem, because it really changes problem to problem. It depends how high you start your object, how fast, it just depends on a lot of things that dirt you have to memorize, but this you don't have to. They always start out with like a negative 16t squared, but everything past that point changes. So the height and the time are what our h and our t stand for. And what we would have been asked previously, like how high is the rocket after 1 second? 1 second means time equals 1. So what we would have done is taken our h, just like it was, and instead of the t's, we would have put in 1s. They could have asked us after 2 seconds, we would have put in 2s. And we just simply would have worked this out. Okay, so 96, what is that? 80. Okay, so that's the type of thing that we did a few chapters ago with this. We were just given a function back when we were learning about functions and asked to plug in different things for time. Okay, so now what the practice problem says is, when does whatever your object is, in this case a rocket, hit the ground? And the key word is the object returning to the ground. It doesn't say it explicitly because it wants us to figure it out, of course. Hitting the ground always means that we need to think about the height being 0. And so height is h equals to 0. So what you're going to do in these problems, and this is as far into the applications as we will get, mostly because we see these things pretty often in algebra. If this is h, we are going to have to take whatever h is and set it equal to 0. And it turns into a factor and solve. Now it looks nasty and it looks weird because we don't have x's, we have t's, but the rules still apply. Is there an overall GCF? Well, we can see that both terms share a t, so we can pull a t out. And additionally, both terms are divisible by 16, so we could pull a 16 out. And then something that we haven't seen in too many problems is if your GCF, or if your lead term here is negative, your GCF needs to pick up that negative just to make the rest of the problem either simpler, or in the case of like factor by grouping, it needed to come out to make the problem possible. So for us, if we divide out a negative 16t, very carefully here. So this is our GCF. If I'm dividing out, so I can watch the canceling, that is going to leave me with a, oops, where'd my drawing go? That's going to leave me with a t. The negative came out, so this will also turn negative. And then what is that? Yeah, that's a 6. So this is my factored form. And I really don't need to count the terms or do anything beyond that. I just need to set, I've got 2 pieces. I've got the GCF and I've got the leftovers. Set those equal to 0 separately. If I divide by -16 both sides, t is going to equal 0, and t is going to equal 6. And this is seconds. Okay. So all you do in these problems, different from what we used to do, you're going to be asked when something hits the ground. So you set your equation equal to 0. You factor out, usually you get to pull out -16 and something. And then you set what's left equal to 0. Let me write the homework down real quick, because this will be our last homework for the entire chapter. And a lot of it, I just kind of kept it to the basics here. There's those that are the regular factoring problems. And then there is 81 that is like what we just did up here. Yeah, 81, and then 87 is also like what we did up here, but I'm going to put a star by it. This is your challenge problem just because the factoring in there is a little bit harder. Yeah, let me leave it at that. Okay, so that is it. That's the homework. Again, I'll be sending out the worksheets over the weekend, and then probably after the weekend, around the time that we come back to class on Tuesday, somewhere in there, Monday or Tuesday, I'll send out tests, but no deadlines have been set on anything yet. No deadlines on worksheets, no deadlines on tests. We'll talk about all of that next week when we see how Valor's doing and we see how we feel about the material, because this is just a gigantic load of material. So I'll end it at that and go ahead and make sure that I can get this recording loaded onto YouTube for you guys. So have a good weekend, and I'll see you on Tuesday.
Okay, thank you so much. Have a great week.
Thanks, you too.